In problem number 1, we are asked to find if the drug DHEA has an effect on memory, and to measure this effect, they recorded the number of words that could be recalled in a certain time period after taking the drug. The sample mean, which is the number of words that could be recalled on average by the treatment group, is given to us in the problem to be 10.9, whereas the population mean is said to be known to be 9.2. In order to test to see if our sample is significantly different from the average population, we are going to conduct the t-test. The general formula is shown here, and this will give us a t-statistic, which we will then turn into a p-value, and that will allow us to conclude one way or the other. We start by checking our conditions for this t-test by looking at the data for the problem. I've shown the data as a histogram here, and from the data we can tell that it is approximately normal. We can see one peak right around 10, and we can also see that even though there are values at 4 and 18 which appear to be far away, they are close enough to the mean that we do not have to consider them outliers. Generally, I think you would need more values than just 9 data points, but I'm assuming they don't want the test to fail for not having enough data. As we move on, we will assume as long as we can accept that the data is approximately normal, we can move on with doing our hypothesis test. At this stage, we will state our two hypotheses. Since we were given a sample mean and a population mean, we are going to use the null hypothesis that there is no difference between the two means. That is, the mean of the sampling distribution, which is given here, and the mean of the population, which is given here. In writing it this way, with one mean subtracting the other mean equal to 0, we are able to construct a normal distribution where we expect the mean difference to be 0, and we'll eventually calculate the standard deviations of those distant differences, and from that we can approximate the p-value given to us in the problem. In order to calculate this distribution, we need to move on to calculating our t-statistic and also our standard error. In this case, they gave to us the sample mean of 10.9 with the population mean given as 9.2. Then for the bottom of the fraction, we have our sigma, which is 3.78. 3.79 divided by the square root of n, which in our case is 9. Now, if we do this calculation, we will get that our t-value is going to be equal to 1.34, and with this t-value, by looking up in the back of the chart with 8 degrees of freedom, which is 9 minus 1, we find that our p-value is going to be 0.108. Based on this p-value, we cannot reject the null hypothesis. With a 10.8% chance of obtaining the sample, we cannot reject that there is no difference in the population means. We have to assume that the drug does not have an effect on the amount of words that can be recalled, and further study would be needed. Now, the final question that they ask in Part B is about the percent of the variance that can be explained by the experiment. This is given by our formula over here, which it's just an approximation. And in order to do this, we're just going to put our standard deviation from the sample, 3.79, over the mean, which is 9.2. and we'll use the population mean since that is known, and we get that it's 41.2%. So we can say that 41.2% of the variation in the data for our sample can be explained by the effect of the drug DHEA. This is to say that we're not entirely sure why the data values are different. There's still 60% unknown reason as to why the data has changed, but 40% of the change in the data that we see from the general population can be explained by use of the drug.